This lecture is an introduction to the material that we're going to cover in this course in the context of an important and familiar application. We're going to try to give you some idea of what computer science is all about as a prelude to all the material that we're going to cover in this course. Let's begin with a brief introduction to what computer science is all about. Very basic question, what is this course about? Well, it's a broad introduction to computer science. Our goals are first to demystify computer systems, to give you an understanding of what goes on inside the computer that you use. Second, to empower you to exploit available technology. Whatever endeavor you choose, you're going to be using a computer, and people who know how to use computers effectively are going to be much more successful in their endeavors than people who don't. And the third one is also important, and that is to build some kind of awareness of the substantial intellectual underpinnings of computer science. This is often overlooked by many people who dive in to make use of the technology without really understanding that computation has been studied intensely by researchers of all stripes for decades. And there's quite a bit actually of understanding of what computation is all about, way more so than in some other sciences. So the topics that we're going to consider first of all is programming in Java. In order to really understand what computer science is all about, you need a broad facility in the ability to program in Java, in some programming language, and we picked Java. Fortunately, this is also very useful in a practical sense because programming in Java is something that you can use effectively in all kinds of future endeavors. We're going to talk about the design and architecture of computers, how they are actually built down from the smallest component up to the biggest computer. Seems like an ambitious goal, but as you'll see, it's possible for us to explain to you really how the computer is put together. And then, as I mentioned, we're going to talk about theory, about the whole idea of the theory of computation and what computation means and how it relates to the natural world. This is a beautiful theory that had been developed starting in the 1930s and also has really important practical implications. And all of these things we're going to do in the context of actual applications in science, engineering, and commercial computing. We don't use toy problems, we use real problems to illustrate the basic principles that we want to cover all across the board, whether we're talking about programming or architecture or theory. And so every lecture that we cover will have some coverage of important application. We don't do toy problems. Not just science and engineering, art, music, finance, many other fields. Computation really touches everything nowadays, so there's no shortage of application. I want to just to get people thinking about what computer science really is about. I want to start with a quote by Don Knuth, who's one of the earliest and most famous computer scientists. And he says, "Science is everything we understand well enough to explain to a computer." Some people say, well, why is it computer science? What's the science in computation? And we'll definitely cover that. But I think the interplay between computation and science nowadays is very well established. There's many opportunities to take an understanding of computation and develop that into a better understanding of the natural world. And in fact, we have another famous quote from a famous scientist that everyone knows. Pretty early on in the life of computation, said this: "Computers are incredibly fast, accurate, and stupid. Humans are incredibly slow, inaccurate, and brilliant. But together they're powerful beyond imagination." That's really what we want to talk about in this course, is the ways in which people can exploit the incredible development of computation over the past several decades.